Hi, my name is Mara and I'm a researcher here at ICSA Research Lab in Riga Technical University. We are researching in several artificial intelligence related areas, including machine learning. In general, machine learning is a process through which artificial system acquires new knowledge. Since we are now moving towards truly autonomous systems, the ability to adapt and learn are crucial features. Depending on what a computer needs to learn, there are several approaches to machine learning. Today we will focus on one of them, supervised machine learning. In supervised machine learning, machine, or a learner, receives correct answers similarly as a student from a teacher. By learning from these correct examples, the computer is able not only to recognize already seen examples, but also to generalize, find patterns, and thus understand unseen data as well. This is the core feature of supervised machine learning.
In case of mobile robots, there should be a path planning, because if we have to navigate the environment, we should know what obstacles there will be and how to get to the goal. I'm trying to solve the problem that value iteration algorithm for path planning is sometimes too slow and it can't be used real-time on robots. So I'm trying to use convolutional neural networks to improve the performance, and so it can be used on robots in real time. My model inputs are maps with obstacles and the goal to which robot should go, and the output is a value map. By following these values, robot can go to the goal. So we have input maps that are going through my neural network model, and the output are the value maps. You can see them here. This is one of the most successful models. Its accuracy is more than 90%. The metric that I'm using is success rate. When we're completing each map, we're going through with the extra algorithm to check how many of these discrete spaces can go to the goal. And after testing these convolutional networks, we went on and tested the recurrent neural networks. That's like we're imitating value iteration algorithm and we're trying to force it to work in less iterations and in faster speed. So here it's possible to see how we are starting. We're starting with just the input map, and slowly with each iteration the algorithm fills in the map with the gradient. And from each of these discrete points we can go to the goal. Basically, any neural network inputs could be any vector or matrix, so it could be any image, it could be any data that you can find, and the outputs can be anything that you can define as a class or another image or vector data. Image segmentation for medicine could be MRI scan of a patient, and the output could be the same MRI scan with highlighted spots of interest for the doctor. These models could be used for anybody who's interested in computer vision, robotics, quality control, and mostly any field there's input data and known output data that should be learned.
Is there anything your robot or computer needs to learn? Do you want to be engaged in this or any other of our topics? Let us know.